So in this video right here, what we want to do is we want to do what the instructions say. We want to match the function. We want to match the function with its graph. So we got to figure out, like number 15, which one of these four graphs goes with this function. And when we're done, we want to describe the range and the domain. And so let's get started. Now, we know that if you look at 15 and 17, we know that when the negative 3 is under the radical, it causes horizontal shift. Horizontal shift. Now, horizontal shift is left and right. Okay, now we know that when the negative 3 is not, you see the radical ends right here. So the negative 3 is not under the radical. When that's the case, it causes vertical shift. Vertical shift is up and down. Okay, and so we know that this function right here is the parent graph of square root of x, but they moved it down 3 on the y-axis. So the new y, instead of the y-intercept being at 0, 0, it's going to be at 0, negative 3. And so let's look at our functions. And so let's look at a and a first. Okay, you can see a is basically the parent graph, and the only difference from the parent graph and a is it has been shifted down 3. Okay, that's what a's got going on. And look at b. B is flipped around. It's kind of the parent graph, but it's going left instead of right. Look at c. Instead of c taking the normal square root function, it's growing really fast. Instead of it going like this, it's growing real fast. And then d looks like the regular square root function, but instead of it starting at 0, 0 and moving to the right, it's shifted right 3 and then it's moving to the right. Okay. Now, obviously, immediately I notice that 17 is a. And the reason is, we're going to say this is 17. 17's a because this negative 3 right here gives us vertical shift. It just tells us that we take the normal parent graph and move it down 3 units, which we did, and that's the graph you get. So 17 is obviously a. Now, we can check our answer, and here's how. You can see that when somebody plugs in 4 for x, they should get out negative 1. Okay, so let's take the function for 17 and let's plug 4 in. Okay, so over here I'm going to write 17's function is square root of x minus 3. And in the place of x, I'm going to put a 4. And we said when we plug in 4 as our input, 1 should be our output. And so I've got the square root of 4 minus 3. I'm sorry, negative 1 should be our output. So the square root of 4 is 2 minus 3 equals negative 1. So when we input 4 into the function, our output was negative 1. And let's look at our graph and be sure that that's true. You can see that when we input 4, our output should be negative 1 right here. So 17 is definitely a. Okay. Now the next one I'm going to focus on is going to be d. Okay, d is the parent graph of the square root of x. But instead of it starting here at 0, 0, it starts at 1, 2, 3 right here. And so we have to ask ourselves, which function gives us horizontal shift? And it's 15. 15 provides us horizontal shift. Now we need to make sure that what's under this radical provides us with a horizontal shift of 3, because that's what this function has. So the way you can do that is you can take what's under the radical, the x minus 3, and set it equal to 0. So let's take the x minus 3 and let's set it equal to 0 and let's solve it. So I'll add 3 on both sides and I get x equals 3. So our horizontal shift should be right to 3 on the x-axis. Okay. Well, let's look at our function on d. Is our horizontal shift at 3 on the x-axis? It is. Now we can check our answer just the same way as we did on the previous problem. You can see on this one when you plug 4 in for x, you should get 1 out for y. So let's look at the function. We're saying 15 is the correct function. Let's plug 4 into it. So I'm going to take this function square root of x minus 3 and I'm going to plug 4 into it. So I have the square root of 4 minus 3. Okay, so that's the square root of 1, and that equals 1. So when I input 4, my output is 1. And let's look at the graph and make sure that's what we want. When I input 4, my output should be 1, and it is. So definitely D is 15. So I'm going to write a 15 right here. Okay. Now B is much easier. If you notice, all the graphs are moving up and to the right. Okay, up and to the right, up and to the right, up and to the right. The only one that's not is B. So what caused this to reflect on the y-axis? Well, what caused it to reflect on the y-axis is when there's a negative in front of the x. See how right here there is a negative in front of the x? That causes it to flip on the y-axis, and instead of moving up and to the right, it begins to move up and to the left. And so in this case, B is very easy. Okay, B is definitely 18. And so by process of elimination, we know that C ought to be 16, but I want you to understand why C is 16. The reason C is 16 is, do you see in front of the function on 16, there's a 3? What that means is whatever we plug in for x and evaluate, we're going to multiply it by 3, so it's going to grow much faster than the rest of these functions. And so that 3 is what's causing the graph to move. See how the rest of them move? The parent function kind of looks like this. So if I were to draw the parent function of square root of x, it would look something like this, right? But the function they did draw goes up and to the right much faster, and that's because of the 3 in front of it. So we know that that's definitely 16. So now what we want to do is evaluate the domain and range of each of these. Okay, now let's first talk about what domain and range are. So domain is simply how far left does the graph go and how far right does the graph go. And you're looking at the values on the x-axis. Okay? And then when we're talking about range is not left and right, it's how far down does the graph go and how far up does the graph go. And we're looking at the y-axis values. Okay? So let's go do some problems. So when we look at A right here, and we want to tell the domain and range of A, okay? The domain on A, I'm going to write a D equals here and an R equals for range. So the domain is how far left does it go? Well, you can see that the furthest left it goes is right here. Okay, does that mean my domain's at -3 because it's -2, -3? No, see, this is the y-axis, but for the domain, we look at the x-axis. So where is this on the x-axis? It's at 0. So the furthest left it goes is 0, and then it goes right forever. That's positive infinity. So our domain is 0 to positive infinity. Okay, now let's look at the range. Now the graph comes all the way down to right here. And would that be 0 or would it be -3? Well, since that's the range, we look at the y-axis, and that's at -3 on the y-axis. So the starting point is -3. And then it goes up and to the right forever. See, it's going up and to the right forever, and so it ends at positive infinity. So that's the domain and range of the graph A. I'd encourage you to pause and see if you can calculate the domain and range for B, C, and D. Okay, let's go find the domain and range on B. So I'm going to write down D equals for domain and R equals for range. And the graph goes up and to the left forever. Okay, so when we ask for domain, we say how far left does it go? Well, left forever is called negative infinity. And then it comes all the way to 3 right here. So it goes from negative infinity all the way to 3. Negative infinity all the way to 3. And then the range, it starts here and it goes up forever. Well, this isn't 3. Remember, when we're talking about range, we look at the y-axis, and on the y-axis, that's 0. So it goes from 0 to positive infinity. Okay, now let's scroll down and do the domain and range on 15. Okay, so on 15, I'm going to write a D equals for the domain and an R equals for the range. And remember, domain is how far left does it go. Well, this is the furthest left it goes, and on the x-axis that's 3. So it starts at 3 and then it moves right forever, so we call that positive infinity. And then the range, it goes down to here. Well, that's not 3. Remember, range, we look at the y-axis, and on the y-axis that's 0. So it starts at 0 and it goes up forever, which we call positive infinity. Let's move over to our last one. Let's find the domain and range of C. So again, I'm going to write D equals and R equals. And I can see that for the domain, remember, we tell how far left it goes. Well, this is the furthest left it goes, and that's 0. So it starts at 0 and it moves right forever, so we call that infinity. And then on the range, it also goes down. 0 is the lowest it goes down, and it goes up forever, so that's also called infinity. So on C, the domain and range are the same.